Hello, welcome to this video where I shall help you understand how do you conduct the chi-square test using Minitab. The chi-square test shall lie in the stats menu. So if you click stats, go to tables, you have the three options of the chi-square test. The first one referred to as cross tabulation and chi-square, which is to be used when you have two categorical information. Second test, chi-square goodness of fit, also referred to as one variable, to be done when you have y, which is numeric data, and x, which is categorical data. The third test, chi-square two-way table, when you have both x and y as numeric data. But you must always remember that chi-square is a test for discrete data only. So the test will not be conducted should you have either y or x, which is continuous. So let's look at the first option, cross tabulation, to be done when both your y and your x are categorical data. So I have data in the column C5, which is CSAT rating, and I would wish to compare it against marital status. Both are categorical data. To be able to conduct the chi-square test, I will have to click chi-square and check this box here, chi-square analysis. Press OK, OK, and you have the p-value, which shall help you determine whether the x significantly impacts your y or not. It is saying that marital status does not significantly impact CSAT scores. Now let's look at the other two tests of the chi-square family. I have collected data for quality scores, which is in count, and PKT, process knowledge test scores, which is again in count. So if I were to look at using the second option, so let's say I go to tables, I go to two-way table, when both are numeric data. So I can compare quality to PKT or quality to typing speed. Press OK, and this shall publish you a p-value. You must always understand that whenever you are conducting the two-way table test for chi-square, if your data has decimals, it will not allow you to conduct the test. So you must be careful about the source of the data that you've used. Even in your Excel sheet, if you have data with decimals, chi-square understands decimals as continuous data, and hence it will not allow you to conduct the test. The third option that we have to use is the one variable. So you go to stats, you go to tables, you go to one variable. So let's say I want to compare quality with trainer. One is numeric data, the other is categorical data. You must always understand that chi-square one variable test shall always by default look at equal proportion, meaning that you are under the assumption that all trainers have trained similar number of people for the process, or that the number of samples taken for associates belonging to each trainer is equal. Press OK, and it will give you the p-value to understand whether the x impacts your y or not. This is a very important graph. The orange bar is showing the expected count. The blue bar is showing the observed count. So whenever there is significant difference between expected and observed, the p-value will be less than 0.05. But one thing that you must be cautious about is the fact that we are using equal proportion. You should use this option when you are very, very sure about the samples being the same size. Let me look at a different example for you. So let's say we have data on count of attrition, and we have the names of departments. So we've had from the admin team, let's say we've had 4 attritions. From the HR, we have had 14 attritions. From the operations, we have had 612 attritions. While from leadership, we've only had 3 attritions. From the quality team, we've had 34 attritions. When I have data of this sort, I can use count of attrition versus the department. However, looking at the equal proportion here may not be the correct method to use, largely because the number of people in these departments will be significantly different. So admin teams ideally will be much smaller teams, while operations teams will be much bigger teams. So what you should do is you should look at the head count of these departments. So let's say that the admin team was a total of 10 people. HR team was a team of 25 people. Operations was a team of 3,000 people. Leadership had 15 people. Quality was a 100 people team. This is the head count of the teams. You should now draw proportion from the head counts that is available. So if I were to sum this up, you essentially are saying that you have, out of these 5 departments, you have a total of 3,150 people. So as a proportion, the admin team is only 10 upon 3150. HR is 25 upon 3150. Operations is 3000 upon 3150. While leadership is 15 upon 3150. And quality is 100 upon 3150. So this is your total proportion. To be able to check whether your proportions is correct or not, when you add this proportion, it shall always be equal to 1. So now create this data, go back to your Minitab sheet and paste. So now that I have created that data on proportions, I will now conduct the test. I go to stats, go to tables, choose one variable. In the observed count, I will put in the count of attrition. In the category name, I will put in department. Instead of equal proportion, now I will choose specific proportion and give it the data for proportions that I have. Press OK and your test is now done. If you see now, your expected, the orange bars is not the same for all the departments. It is varying by the department. That should be the correct method of doing it. Had I chosen equal proportion, my orange bars for all are same. This is not the correct way of doing it. The correct way would be to draw proportions out of them, because when I look at the data in silo, when I look at operations, it has had 6,612 attritions. However, the head count of the department was also very high. Hence, it is advisable to use specific proportion. I would go to the extent of saying, unless you are super sure, you should never use equal proportion. You must seek the logic of the distribution and then decide the proportions accordingly. I hope you find this simple video helpful.